Okay. This session is now being recorded, and I'm going to lower your hands, and we're going to talk about photoresistors today. Um, let's see here. Let us present. So, photoresistors, or light detecting resistors, or LDRs for short. You can hear them from both sides. Some people call them photoresistors. They're also referred to as LDRs. And they are analog sensors, which you can use a bunch of robotics and Arduino platforms and things like that. Uh, One thing to do is make sure your Pi is up and running. So if your Pi is up and running, let me know, please. Again, raise your hands if your Pi is up and running. All right, I'm going to wait for a little while to let everybody their Pi is up and running. While I'm doing that, we can go over some review of this, and so let me lower everybody's hands, and we can start to review some stuff. Today, before we do that, we're going to talk about the agenda. We're going to go through more coding with the Arduino. We're going to recap on some MyBlink codes and functions that we went over last time. Some more terminology, some electronics, things about photoresistors. We're going to talk about applications. We talk about analog sensors, and also we are going to program it and use it today, I hope. If not, we'll get to it later on. But I think we have enough time. And like I said, if we don't fret. We can always go to next time. There's enough time in the classes to in our 8-hour class that we can get to some other stuff as well. So, what part of the Arduino is this? So let me ask this question again. I'm going to lower your hands, and what part of the Arduino is this? Jacob, I'm going to unmute you and see what happens. Jacob, you're there.
Yes, I'm here. Yeah, that's a analog
Analog.
input.
Yes, perfect. Thank you, Jacob. I appreciate that. Awesome job, as usual. Uh, Now let's continue on. And now, a little more difficult question, I think. But what is the pin mode? I'm going to lower your hands. And what does the pin mode do? And what is it? What is it? Does anybody know? Jeremiah, you're the first to kind of come up. So I'm going to unmute you. And Jeremiah, you there?
Yeah,
All right, Jeremiah, what is pin mode?
it lets you set up a pin as an input or an output.
Awesome. Jeremiah, great job. Thank you so much. Let's continue on with our little review here. And again, these are just these review questions just kind of get us warmed up. It's kind of like when I used to run in college and professionally, we'd have to warm up our muscles. This is kind of like warming up our brains. So we have to go over a little bit over what we went through, so we can kind of smooth transition onto the future. So uh, as Jeremiah said, pin mode was a built-in function that initializes what pin. In this case, this is the LD pin, and it is an output. So it's saying that it's an output. So what is digital write? Anybody have any? Brandon, I think I saw your hand up. Unless you were, let me unmute you. Brandon.
Sorry, that was just answering for the last question.
Ah, all right, good
Okay.
guy. All right, do you have an answer for this one? No.
Um,
Well, you can
I
also look.
believe that
Yep.
I believe that is saying whether or not the pin is on or off.
Perfect. Hey, great job. Put you on the spot, and you did very well. Thank you, Brendan. All right, so let's continue on down. And Brendan was right. Sketch tells the Arduino that it is a digital signal, not an analog signal, which we'll actually be talking about today. So this is digital. It's either on or off. high or low, you could call it, and it also sets the pin. So good job. Now, what we can do is once you get it up and running, we could start to connect the Arduino to the Raspberry Pi. So if you don't have your Arduino out, let's get it and let us start. So again, I will slow down if you have any questions. Let's see if you have any questions so far. All right, Jeremiah said I made a program using the LDR that turns on an LED when lights in the room are off. Awesome. You're way ahead of us, Jeremiah. That's awesome. And Ari, yes, you weren't here last week. That's all right. Continue on with what we can do. So let us start. So today, this is what you're going to need. So what I'm going to do is hands are all lowered. When you get all of this, let me see your hand. So we need the Arduino, one thing. And then we need the half breadboard. Then we need with photoresistor. If you want to see a live photoresistor, this is a live photoresistor right here. You did get that package. You didn't get that pack. You didn't get that in the Arduino package. You got it in a Raspberry Pi packet, which is a different packet. So yes, we are using that, and they are electronic components. Can be used for both. So when you do that, or when you pull that out, to make sure you have LDR, or also it's known as a photoresistor. One thing to note, we have a brown, black, orange, and gold. That gold is that percentage, that 5%. But what is the brown black? What ohm resistor is the brown black? That's a question I will be asking. You don't know that already, but these are the components that you need for today. Also along the lines of 3 wires. Now, typically we have a black wire for ground, red wire for voltage, and either some other color, usually yellow for signal, orange, white, those kind of things for signals. So when everybody has this, let me see a raise of hands. Right now I'm only seeing 1, 2 right now. So I'm going to leave it on here, and we are going to just take a look at this. So now we have 3, 4, 5. Awesome. 7, 8. Good. 6, 7, 8. Perfect. Going to be a little bit longer before everybody has this, and these are the components you will use for today. Again, let's move on, because you know the basic Arduino, you know the half breadboard. We have 3 wires. Now let's move on. So what is a photoresistor? I'm going to lower everybody's hand, and let me know if you have any questions, and we'll go back and forth trying to figure all of this out. So I'm going to lower all your hands, and I've talked about a photoresistor. I said it was an LDR, and I said it was some sensor. So we know that it's a sensor, but what else is it? More detailed explanation. So what is, and this is something this is to gauge your knowledge, not to necessarily this answer, because we didn't talk about photoresistors yet. At least I didn't talk about photoresistors. So give me a raise of hands who wants to take a stab at photoresistor. And I saw your hand up first, so I'm going to unmute you, and you're going to answer this question. Anne.
Hello?
Yes, Anne.
Okay, a photoresistor, I think it detects the light, so when you put your hand over it, or when you turn the lights out, the light gets dimmer, and when there's more light in the room, then the light bulb, the LED, gets brighter when it blinks.
That's absolutely correct. That is the total application of photoresistor. Actually, to go into more depth than that, it actually changes the resistance. This is one of the coolest little devices out there, and they're only $0.25. You can buy them from China for $0.25 each. They're very inexpensive. They're used in multiple applications, And not just it can turn on an LED, but if you can imagine not only an LED, but maybe a motor, maybe a servo, maybe something else, maybe a car door or something like that. Changes a lot. So it's a sensor, and it's just not doesn't necessarily mean have to be hooked up to an LED. A lot of line following robots do have LDRs in them to follow the lines. So again, you're changing the motor speed, not just on a light. So one thing is, this is the physical picture. So I'm going to lower everybody's hands and let me know if you have everything by raising your hand. Let me know if you have everything for today. Let me go back to that slide. All right. All right. All right. So again, most of us, and we'll be using this, but at a later time. So that's all right if you don't have it yet, but make sure you get that. So let's continue on. And I asked you last time, what is the value of a brown, black, orange, gold resistor? It is a 10 kilo ohm resistor. The brown stands for 1. The 0 stands for the black stands for 0, and the orange stands for 3, which is kilo ohm. So again, I'm going to lower your hands. We need all of this to go on today with what we are talking about. Let me see if there's anybody have any questions. Awesome, no questions yet. And again, this is one of the coolest sensors, I think. It is an analog sensor, so we will be learning a little bit about analog. Again, it is a 10 kilo ohm resistor, not the 450 ohm resistor we did last week or used last week. This is the 10 kilo ohm. This is 2 orders of magnitude more than what we've been talking about, more resistance. So make sure it is a 10 kilo ohm resistor and not a 540. That is important. So a 10 kilo ohm resistor. So if you think about this, the way they work, it's really neat. It's actually silicon based, and it's whenever it detects light, whenever you shine more light on it, it lowers the resistivity, and whenever you put darkness on it, it raises the resistivity. So what's going on in the circuit is, if you raise the resistivity of the resistor, less electrons will get through, meaning the current drops. So if you can imagine this, close your eyes, and I'm going to go to full mode for now. If you close your eyes, and everyone do this, close your eyes. If you're in a well-lit room, that'll be fine, and move your hand over your eyes. Just move it, and you can see some dimness to it. So that's what you're seeing, the dimness of it. So as you saw the change, I hope if you did the exercise, you saw the change in light intensity. Now, what the photoresistor does not do, it doesn't see clear images as your eye. Your eye is very complex. Uh, uh, and the photoresistor, although it is complex for electronics, it is not as complex as your eye. So it's kind of, like I said, it's like your eye closed. So imagine that. It doesn't see things far away. It can't see, but it sees things up close, and it's the light intensity that that the photoresistor sees. So again, just some things, photoresistors see light the same way. That meaning the physics of it, I'm not going to get too much into it, but it actually sees the same wavelengths or similar wavelengths to your eye. So you see there's a spectrum of light, and you only see a small portion of that spectrum. All these rays and all these photons are shooting around. You don't even know they're there. Radio waves, ultraviolet rays, infrared, all of these light waves that you can't see at all, but they're out there. It's really interesting to kind of think about it. And they're flying past your head right now. You just can't see them or detect them. But what's cool about this photoresistor is it detects kind of the way your light is, your eyes do. So it detects this kind of the similar wavelength. Um, Again, it detects light intensity, but it's not clear images. It doesn't see like your eye. It just sees like your eyes closed, basically. So if you close your eyes again and you wave your hand over again, that's the way uh, the light, the photoresistor works. Uh, so, and it detects what's close to what your eye sees. Again, it detects the wavelength. And again, you can't really see out too far of with if you put your arm way out far from the light source and way out far from you, it doesn't. If you close your eyes, it doesn't really detect that. It detects of what's kind of up close. So there is a limit to these photoresistors, but just to know that there's a limit and to know what they are used for, that's very powerful, especially when you're building circuits or robots or something like that. And they are not used for detecting infrared and ultraviolet. And this, like I said, this is the really cool thing about physics. There's more out there than can be explained. There's more out there that you have no clue, that your body can either sense, either taste, touch, feel, see, smell. All of these things that although we're very complicated, we we can't even detect some things that are out there now. Uh, and again, with the photoresistor, it detects the same way your eyes do. Uh, and again, to wrap it all up for the photoresistor simulation, photoresistors are analog sensors. That means that they see a range. And they'll see a range in the Arduino today. There will be a range of 0 to a number, which is 1023. And we'll talk about that in a little bit. Right now, I'm going to ask if there's any questions. Anybody have any questions? Can you get a photoresistor for other electromagnetic radiation? That's a good question. Actually, I don't know the answer to that. That's a great question. I'm sure you can, not necessarily a photoresistor, but I'm sure you can get some other sensor, electromagnetic sensor for radiation. There's actually radiation sensors that when excuse me, when you're going to a nuclear power plant, they have these sensors on your badges which change a different color, and if it changes to a certain color, you better run, basically. So, great question, Jacob. Great question. And Gerald said yes, they're called Geiger counters. Yes, that's a whole nother. I didn't know that there were photoresistors per se, but Gerald, Mr. Holt said yes, they are Geiger counters. Thank you, Mr. Holt. I appreciate that. All right, let's keep moving on. So again, photoresistors are less resistant to electrical current with the more light intensity, as I'm repeating myself now, but it's good to hear it over and over again until you fully understand it. So some applications for this: streetlights. Streetlights, which is a fascinating. I don't know if you know. There's not some guy running up the pole turning on your lights, your street lights as it gets dark. They are sensors, and they are photoresistor sensors, most of them. And the ones for the garden, if your parents or you have a garden, or anybody has a garden, those lights on the sidewalk, they are also photoresistors. So basically, we're building a circuit like that. Uh, they are used in car headlights that turn on at night and dim when a car approaches, which is fantastic. Some more applications of that. And as you can see, that's a Mercedes that I got that from. So even in the higher end and some of the and lower ends nowadays, they do have that application to it. Here's some other applications. Alarm clocks. If you have a night light, I did when I was little, and I wish I still did, so I wouldn't get up in the middle of the night and bump my knee on my bed. Maybe I do need one. So, but anyway, there are photoresistors in them as well, and of course, toy and um, industrial robots have them as well. So, let me ask a question, or let's continue on and excuse me. Let's see. Let me raise a hands who has the Arduino and the Raspberry Pi running, not the Arduino connected to the Raspberry Pi. Well, let's connect your Arduino to your Raspberry Pi now, and then when you're done, raise your hand. All right, looks like most of you are. And when you get there and you turn on your Raspberry Pi, open up your command prompt. I think it's called a terminal. Raspberry Pi calls it a terminal, also a command prompt. And type in Arduino and hit the enter key. So I'm going to lower your hands, and when you see the let's see, this sketch, raise your hand. Good, 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 good. Great job. Great job. See if there's any more questions here. Yes, there are some in smoke detectors too. Actually, that's a really good point, Jacob. Yes, smoke detectors. Some smoke detectors work because photoresistors are in smoke detectors, and they actually, when smoke gets in there, it does lose light intensity, which is kind of cool. So, thank you, Jacob. I appreciate that. And let's see where everybody is. Most people got it. When you're up and running, that's all right. We're going to start using some code. And again, you do not need your Raspberry Pi for this, but however, it is very beneficial to have it. You can use your computer, and if you're using your computer, I know that if you downloaded drivers, that's great. Just to let you know, there is multiple options for you to let's use this program. So I'm going to lower your hands now, and let's start talking about writing the code here. So what do these represent? The forward slash and the star. They represent part of the code where the computer doesn't read, but it makes it more beneficial to humans. Again, what I would do with your code, since it's just beginning, and this is the code that's downloaded. I think I downloaded it from Arduino's website, I believe. Maybe not some other website. It's pretty solid code. I did not write the code, but you have to say where you, in my opinion, you have to tell people where you've gotten it. So these represent the forward slash and the star represented. Anything in between those characters, the program doesn't read, but it makes it more easy for a person to read. So again, this is you do to put this in here, and you can put something, not something, you can put something as complex as this. You can say photoresistor project or photoresistor program, something like that nature. You can go in a little more depth if you want, but we're just learning it, and you can always change it later on. So again, I'm going to ask you, and this is the first line of code that's really going to happen. What does int mean? So we're going to put in int light pin equals 0 semicolon. So what does the int mean? Can I have a raise of hands for someone who wants to take a stab at what int is? Oh, Jacob and Jeremiah. I think I saw Jeremiah's hand up first. Jeremiah, how you doing? Jeremiah.
Good.
Good. What does the int mean?
Yeah. Integer.
Integer. Absolutely. Do you know what values it does? And that's something that I'm going to ask in a second. If not, that's fine. But it does mean integer. So again, you can't put any decimals in an integer file. It'll just cut them off. So now the question I have is, does an integer value range from 0 to 2 raised to the 31 minus 1? I'm going to lower your hands and see if anybody has, this is a yes or no question. Anybody have a stab at this? Raise your hand, Charles. Charles, I'm trying to unmute you here. There you are. Charles.
Well, actually, it's a bit of a complex question. On modern systems, wait, the microphone on?
Yes,
Uh,
we can hear you.
yes. All right. On modern systems, yes. Although that's just because we happen to use 32-bit integers. In modern systems, you can declare it as, if you use special syntax, as say a 16-bit integer, in which case it would be somewhat different. Or on older systems, back in the day on like a Commodore 64, for example, it would probably be 16-bit, and that value would be significantly lower. That is the range that an integer could be.
They actually be raised to 2 to the 15th, I believe, if you're using 16-bit integers. Thank you, Charles. And actually, from Arduino's standpoint, because of this, it actually goes into negative, so you can actually use a negative as well with the new Arduinos, which is pretty cool. That's a large range of numbers that you can use. So again, light pin. So the line is int light pin. Now this doesn't matter what you call it as long as you know something. You can call it photo pin or Fred pin or Charlie pin or Beth pin, whatever you want. You can name it here as long as you're consistently through the program. So I just named it light. Well, they did. I didn't name it light pin. Someone else named it light pin because that's it's affecting light. Also, the 0, it has to equal 0, and this is the pin. Now, is this going to be an analog pin or digital pin? Let me see a raise of hands. See if it's going to be an analog or a digital pin. Corey, I'm going to unmute you. Corey, you there?
Yeah, I'm there. It's an analog pin. Why else would you put a photoresistor there?
Good call. Good call. Thank you. I'm going to mute Corey. Yes, why else would you put a resistor there? Although it is very common, and one time I did this, I don't know when it was, but I did have, when I was using, I'm not sure if it was an Arduino or another microcontroller, I did have the analog pin hooked up. It wasn't in the analog pin spot, so when we're doing this, I want to make sure that it has to be in an analog pin. It was in a digital pin. I was wondering why it wasn't working. So again, make sure you also have your semicolon. So let's move on and let's see what is void setup and what does the void setup function do. So let me lower your hands and let me show a raise of hands. Who knows what the void setup does and what it is? Jeremiah, I see your hand first. Eachin, Leachin, I'm going to go to Eachin. Yes. Eachin.
It sets up the variables?
Yes, it initializes them. It's called. Awesome, Eachin. Thank you. Awesome. What it does is it sets up the variables. What does the void mean? I'm going to lower your hands. What does the void mean? So I'm going to look for a raise of hands on... Oh, Jeremiah. There you go. Jeremiah, what does the void mean?
That it does not return a value.
Great job. Thank you, Jeremiah. Let me mute you. Yes, it does not return a value at all. It's not going to be an integer, a double, a float, a string, or any other type of character or anything else. So it's not going to return anything. Make sure again when you do a void setup, you do put the parentheses in there, and when you're doing it, they should be orange. So as we start, I'm going to start my mine so I can play kind of catch up with you guys. Again, void setup is a function which starts the program, is run, and returns nothing. It initializes variables, sets the pins, starts using the libraries. So again, much later on, we'll talk about using the libraries. I think in the next class, actually, we'll talk about using some of the libraries. So this is a new one. So anybody can see, or what does the line serial? And it's a capital S, and again, it has to be orange. Dot begin, parentheses 9600, end parentheses, semicolon, do. So this again. If no one raised their hand, that's fine. We did not go over this. This is a new thing that we're going to discuss now. So let me see a raise of hands. Who can take a stab at what this is initializing? Great. So we're in new territory finally. Let me see if mine's up and running. So let's go back. What does serial begin? So the serial is a class. And we will get into a little bit of the difference between classes and object. It's basically the framework. And the way it's saying it's a serial class is used for the communication between the computer and the Arduino. Is fundamentally the language. If you think about it, saying, "Hey, I'm instead of Japanese, I'm speaking English," or I'm speaking Swahili, or Chinese or French or something. That's saying, hey, I'm going to communicate you through serial port. I'm going to communicate you through serial communication. Now, there's also I2 square, I squared C. There's also parallels. But today, and for the most part, the only Arduino goes through serial communication. So, anybody have any questions? I can't hear you. Sound just stopped. We lost your video. Let me raise it. Let me see. Make sure you can do this. Let me show a raise of hands if you can see me and hear me. Show a raise of hands. Who can hear me? No, you can't hear me. Okay. All right. Okay. Connecting. For some reason. Can you hear me now? Connecting to audio. All right. For some reason, I lost you all. Ah. No screen. Good now. Gerald. Can't get up. Awesome. Can't hear you. Your sound just stopped. Oh, man.
Welcome to GoToWebinar, Web Events Made Easy. Welcome to GoToWebinar, Web Events Made Easy.
Hello. Can you hear me now? Raise your hand if you can hear me now. Oh, you gotta be kidding me. Oh, perfect. Some people can. Up and running now. All right. Let me lower your hands. Great. Made some progress here. All right. Yes. Perfect. All right. So let me back up and let's discuss what we were talking about previously. And as the serial is, and again, I don't know where I lost you, so if I back up too far, that's all right. We can live with that. So right in between, right under your void setup, or in those two brackets, we want to write serial.begin 9600 end with a semicolon. So the serial again is like your communication. So it's saying, hey, I'm going to communicate this in English. I'm going to communicate this in Japanese. I'm going to communicate this in parallel, or I'm going to communicate this in I squared C or something like that. Some communication protocol. Right now, we're gonna, and the Arduino talks with the serial. So what that is that's all it's saying. Now again, or furthermore, the begin function is how fast the data moves, or it sets how fast the data moves. So it's kind of like the speed control on your car. It doesn't know what value it is, but it sets it. So that's a real big thing for today, because we're going to be communicating back and forth between the Arduino and the Raspberry Pi. Then what it is, the begin, we go down to 9600. This is your speed of the data. This is called your baud rate. 9600, there's also other ones. But right now, this is the one we'll be using. This is a general way for the Raspberry Pi to be the speed that the Raspberry Pi can communicate fairly well with the Raspberry Pi. So that's basically it for that one. So again, we had the void setup, we have the curly brackets, we have the serial begin, uh, the the 9600 and the semicolon. So now we're going to continue on, and below all of the setup is, and after it closes parentheses, we're going to open up another function, and we're going to open up a loop function. Now I'm going to ask again, what does loop mean? Let me have a raise of hands who wants to take a stab at what loop means. Jeremiah, I saw you. Jeremiah.
It the loop function continually loops throughout when the Arduino is powered.
Great. Thank you. Great job, Jeremiah. Great job. Yes, he is totally correct. And this is the next function in here. So again, right under setup, we go right into the void loop. And when does the loop stop? Never. Continues on as long as it's powered, which is kind of crazy. Even if you reset it, it doesn't. It resets the program and not the actual. Doesn't clear the memory. It just resets the program. So right in your void loop, or in between the braces, there's that serial again. So again, I'm going to lower your hands and ask a question. What does serial mean? Anybody want to take a stab at what serial means? Or what's it analogous to, I should say. It's another way of phrasing it. Austin. Austin didn't raise his hand. Somebody raise their hand. John, I'm going to unmute you. John, how you doing? John?
I think it's, yeah.
Yes, what does serial mean?
I think it means like a number, a certain number that's trying to reach.
Close, John, close. It's actually what it is it sets the language, basically. It's analogous to saying, hey, I'm going to speak Japanese to you, or I'm going to speak English to you. There's serial, and then there's parallel and other such communication protocols out there. But Arduino mostly uses serial. I think it only uses serial, from what I'm saying. So again, we want to use serial, and it is a capital S. So if you see an error in your program, don't fret. The S might not be capitalized. That is common. So further on down the way, we have print line. And you're going to see, we're going to talk about communicating through your Arduino to your Raspberry Pi or the computer you're on, and this is how we do it. PRINTLN stands for print line. So I'm going to lower everybody's hands, and from there, print line. It is a print ln. So, and then you must put brackets or parentheses after that, and then analog read. Now this, the way we're going to hook up our circuit, we're going to hook it on a 5 volt to 0 volts, not 3.3. We are going to hook up our 5 volts. Can you hear me now? I know we were having some problems with this previously. Um, oh, they can't hear me right now. Damn it. I don't want that. We have problems with this. Oh man. So we have some problems here. With the technology. Okay. Can you hear me now? Hello? Yes, great, thank you. All right, we're back on. Sorry about that. It seems to be going in and out today for some apparent reason. The internet is. Again, my internet's trying to connect as well. So be very patient, and I appreciate your patience. So let's continue on. Analog read. Again, reads the analog pin between 0 and 5 volts. We will be hooking the 5 volts up to the 0 through the resistor and the photoresistor. And then it maps it in between the 0 and 1023, which is an 8-bit processor, basically. So I'm going to lower everybody's hands and continue on down. This is void loop serial.print ln analog read light pin. Make sure you put your braces in there. And again, the light pin now refers to the integer contained in the light pin. So again, we had 0 in, and that's what we will be using our A0 on our breadboard. Notice the parentheses. So again, notice the parentheses for this. Let's continue on. Again, we can we can comment any of this out or what we choose. Now it's good to comment your code, so again it makes it more readable to others and a way so you can come back. There's been plenty of times when I wrote code, didn't really comment so well, and came back 3 weeks later and going, what did I do here? That has happened to me more than once, so I'm lesson learned that I'm passing on to you all. So then we're going to stick a delay in here. So the delay function stops and halts the program just for the recommended time or the time allocated in the parentheses. So in this case, this is 1,000 milliseconds, and 1,000 milliseconds does equal 1 second. So let's continue on. Make sure you have your semicolon with you, and again, you can set it up shorter, faster response time. With the Arduino, I noticed that 1,000 or 1,500 is a good delay in the program. Both the Arduino is not as fast as usual computers. However, it is a little fast machine comparatively to other machines that size. Let me make sure, let me pause right now and make sure you can hear me. So raise your hand if you can hear me. I just, like I said, because things are a little choppy, I just want to make sure. Thank you all for letting me know. Now I'm going to put your hands down and let's continue. So again, make sure you open your brackets to the loop and close your brackets to the loop. No, there's a question here. How do you loop a finite number of times? That's a good question, Yeechin. You can actually loop in here, put variables in here in the parentheses in the loop function, and say, hey, I want it to loop for this amount of times. Right now, it is defaulted to an infinite number of times. That is a phenomenal question. Thank you, Eachin, for that question. So right now, your code should look like this. Now, let me get a hands if your code should look like this, or does look like this. In the meantime, I'm going to have to write this code. Oh no, I do have it. So raise your hands if your code looks like this. If not, make so now. And then let me see your hands. This keeps going in and out.
Yeah, okay. What we need to do is hook direct line now. That was the last.
I'll do that in my house too.
Yeah, I'm not hooking for some reason. I'm not working here.
All right. Now we're back on, it looks like, and people are golden. All right, now we're going to spend the next 10 minutes, and I will stay after if anybody would like, because I know we've been having some problems with this. So I really want to get you guys at least rolling somewhat of the way, and then we can start to explain it and wrap up. So again, your hardware connection looks something like this. You put your Arduino next to your half breadboard. So again, get your Arduino next to your half breadboard, and from there, what we're going to do is you're going to connect a black wire or a wire from ground to a column of that. And let me see a raise of hands once this is complete. So again, I want to make sure that we're going very slowly, but going more slowly now will save us trouble in the future, I recognize, especially when teaching. Sometimes I know when I get too fast, and I think we're all golden. All of a sudden, I've lost 99% of the class, and the other percent got it wrong anyway. So why not go kind of slow and go from there? So again, this is good. Make sure when you get this to raise your hand. So your Arduino You're hooking the ground up to some column here. Good. Again, I only have 25% here. I'm going to wait for a little bit more to come by, and then we can move on. Again, raise your hand if you have done this hooking. All right, hello. All right, let me make sure. Yeah, there we go. Raising a hand. What I did is I switched off my wireless and went right to a hard line. And I think I'm going to pretty much do that. I know that we were having some problems with Wi-Fi, and it was worth a shot, but I think that was the thing that was wrong. So let's continue on with the 10K ohm resistor. Put the 10K ohm resistor like this. This is internet. Okay, so put the 10K ohm resistor on one leg of it goes into the column where the ground is coming from, and the other leg goes into a spare column, basically. So it's straddling the breadboard. So let me see a raise of hands when this is complete. %, good. 44%, good. Good. Now we're getting 50%. Good job. Some of you guys are teachers. Good. And I will keep continuing with the same slides. Now what you're going to do is hook up from the leg with the resistor that's not actually hooked up to anything. Hook that up to an analog pin 0. It might be called A0 on yours. This says just 0, but on my Arduino, it actually says A0. So make sure you do hook it up to an analog pin, not a digital pin. I've done that mistake. And I've lowered your hand, so raise your hands to let me know when you are done with that. Got 1, 2, 3, 4, 5, 6, 7%, 8, nice, 9, perfect. All right. Again, don't fret. We will continue on with this. So now you use that resistor. Lower everybody's hands and take your photoresistor. Now you're going to hook it up to the same column that the leg is that's hooked up to the analog 0. Again, that is a must. So basically, in the schematic, you will see that the analog 0 is hooked up and connected to one leg of the 10K ohm resistor and the one leg of the photoresistor. And you also want to straddle that photoresistor to some other column on your breadboard. Then from there, what you're going to do is you're going to close it out. So we're going to close it out to the 5-volt power supply. Now, when you get to this, raise your hand. If you've done all of this, raise your hand. Again, you have the 5. If we take a step back, or if we go backwards from the 5-volt power supply, connected to the column, connected to a photoresistor, excuse me, connected to two things now. We have one leg of the photoresistor connected to the analog 0, and the other is connected to a resistor, 10 kilo ohm resistor. We follow that 10 kilo ohm resistor, and that 10 kilo ohm resistor is hooked up to ground. So let me see a raise of hands if this is complete. Nice, nice. 6%. 6 students, not 6%, 6 students. Let's get a little more before we move on. Again, I'm going to stay over, but you more than welcome to. It is almost 6:30, so you're more than welcome to step out if you want to. I don't want to keep you, but I know that I do want to get through this, and there'll be some review next time. But I do want to make sure that you all get this. Corey, I hope you can see me now, and I can't see you. Let's see here. Corey, I'm gonna unmute you and see if you can hear me and see me. Corey, how you doing?
Nicely, and my photoresistor is getting a bit messy. I still haven't put in the wire to the 5 volt.
That's all right. Can you see that and hear me though? All right.
I can see the fritzing diagram. Yeah.
Perfect. Awesome. Thank you, Corey. All right. So what that looks like is, again, we have the 5 volts. We hook that up to and connect that to a photoresistor. The photoresistor is connected to two things: your analog 0 pin and another resistor. Connected to the resistor, then excuse me, the other resistor is connected to the ground. So we continue on. It looks like this from, I'm going to lower everybody's hands. It looks like this from a schematic standpoint. And again, I'm going to stress this over and over again, that photoresist, this is the symbol for photoresistor. And notice how that this is a schematic for just a resistor. It is a resistor with a circle around it with two arrows, meaning photons. That's a sign for photons. The A0 is connected to there, one leg of the photoresistor. It is a symbol for a photoresistor. This is the symbol for a resistor over here, just to let you know. And this is the symbol for Arduino. Heck, why not? So now we're going to try to click here to verify, compile, and run the program. If you've verified and run the program, you may have errors, because usually what I've done is I have plenty of errors. So go ahead and let me know if it's working. So run the program, and you should see nothing, basically. So let me open mine if I have it. Mine's running. I can't connect it because it's dead. So I'm going to connect it on my Oh, you love technology. So when you get a code that looks like this and you run it, let me know if it's working or not. Now nothing, Brandon, you got it working good. Nothing should be going on until you reach some point. So what I'm going to do is I'm going to upload it. Make sure it's uploading into mine. It's done. Now what do? Nothing's on the screen, right? Let me unmute Brandon and see what he has to say. Brandon, well, you're muted, but Brandon, what are you seeing now since you ran the program? Brandon.
After I ran the program, all it said was, well, pretty much what it shows on your screen down at the bottom of the sketch.
Good call. You know what? Want to see a little trick? Come up here where it says, come up here to this little finding looking glass. This is for your serial port. And this is your serial monitor. Click on your serial monitor. Now this is what it should be doing now. So I'm going to mute you back up. And once the code is running, it should look something like this. Now, if I put my hand over it, it's going to do what? I put my hand over it and it lowers. Take my hand off and it raises. So that's what you should be kind of seeing. I'm going to see for any questions here. I have an error about a serial port error. And it's working. Okay, then what should it do? Absolutely, Yichin. Jacob. It's not. Okay, this is old stuff. Good. It's working, Corey. Awesome. So now what we can do is we can sit around and play around with this, and we can think about how we're going to. Oh, let me back up. And if there's any errors, I know that Austin. Let me see if there's anything we could do for you. Austin, where are you? Austin, I'm gonna mute you, and there we go. So Austin, you there?
Yeah, I'm pretty sure I figured out the problem.
Okay.
Serial port is grayed out in my tools, and I think I just have to restart my Arduino.
Yes, and make sure when your serial connection to it. You mean? Like, well, that's not mine. When you do your file, not tools, serial port.
Yeah, that's grayed out right there. The entire
Okay.
thing.
Is your Arduino connected to your computer?
It's connected to my Pi.
It is.
Yes.
All right. And is the other? So you're getting power to it?
Yeah.
Okay. Disconnect it and try again.
Do I have to reset the Pi if I unplug the Arduino and plug it back in?
I'm sorry, Austin?
Do I have to reset the Pi if I plug the Arduino in and out?
Sometimes mine no, but I've heard they're very sometimes you do. Mine usually you plug it right in. It doesn't matter when, but I've heard that there's an order to it on some of them. But make sure you have that serial port, and then you can. Once you get that serial port, it should work from there. So I'm gonna Austin. I'm gonna mute you, and we'll come back to you in a second. Any more questions? It's working, Corey. Awesome. Fell behind a while ago. So what was the breadboard configuration? I shine a flashlight into it. Great, Corey. Are we leaving? Yes. If you want to stay, you're more than welcome to, Ari. But we it's 6:35. I don't want to keep you for too long. Let me pull back up the configuration for who asked for that? Someone asked for that. Yeechin. Let me go back to Yeechin and unmute you and see if you. Yeechin, is that the slide you were looking for?
Yeah. It seems like the problem seems to be fixed actually.
Great.
I changed one thing.
That one thing could throw you off or save the day. Awesome, Yeechin. It's working. Should we save this? Yes, I would go to save it as whatever you want. Jason, if you want to save it as photoresistor or something like that, be my guest. This is your program, and you can modify it. One thing that I did want to get to, but we're not going to more than likely, is to start to modify some of the code. So your code can look like something like this, where you can actually tell what voltage it's actually pulling out, which is actually real cool. So now it becomes a sensor. So I want to upload that. And Once it's uploading, this actually tells how much volts in integer form. Remember, these are integers. So right now it's 3. If I cover it, it goes down to 1. If I let go and let light shine in, it's 3. I cover it again, it's down to 2. I go more closely to it, it's 1. So yes, there are much things to do with it. It's weird that the second USB port on the Pi, but it works with the first one and is fixed now. Awesome. Great job, Austin. Great job in figuring that out. Some of the ports maybe I know that this needs to be hooked directly to it, so make sure that it is correctly working. I'm saving it as a digital light meter for photography class. Awesome, Corey. Awesome. Now that's all for today. And again, there is some to let you know that when you're seeing the output, not this output, but the previous output, uh, it's was a number between 0 and 123, and that's an analog number. Although it is very discrete in the numbers, it is an analog number, and it can range from any of those positions. So what I'm going to do now is I'm going to go back, and if anybody, we are complete now. I know I don't want to keep you for too long. So again, I had fun. Sorry about the connection problems. Some things, real engineering at work, basically trying to solve that on the fly. So again, you can leave now, or if you have any questions, I'll stay on for another couple minutes possibly right now. But I'm going to mute myself. If you have any questions, raise your hand. Joel, I'm going to unmute you and let me know if you have any thoughts on how today went. I know it was a little quirky, but let me know how it went. And Corey's still on, just to let you know. Corey and I are still on. Joel.
Yeah, hey, everything went, really smoothly. I ironically left behind my photoresistor at work, so I have everything lined up to just plug it in tomorrow. I got my program written up and everything, but of all the components I left behind, it's actually sitting in my, I have a breadboard attached to my Raspberry Pi that I have it plugged into, so go figure, right?
Yeah.
And I've taken pretty much all of my spare electronics to work, so I have none in my house. I'm looking around thinking, like, I know I have a pack of these somewhere. I bet you they're on my desk. But
to let you know, next Wednesday, we are going to do the ultrasonic sensor.
Great. That's awesome.
So that's the one we're going to use. So make sure you have that and a couple of wires in your Arduino.
Yeah.
That should be.
Yeah, it's funny because I have my stuff sort of split between home and work, so I pack up a little box of my stuff from work and take it home with me on class days.
I understand.
But question for you: that ultrasonic sensor, is that the one you can buy on Amazon?
Yes.
Is that where you got this?
Yes.
Yeah, because I always check Amazon because I'm always surprised. Like there's certain things that you can get really good values on, and then there's a couple of things that it's better to get from like SparkFun or places like that.
Absolutely. With these, they are a little different. I know the ones at SparkFun and the what's the other one? Big one. Well, Adafruit and DigiKey. They sell the 3-pin one, and the 3-pin one has a voltage in and a ground, and the third pin is just a one. It's a transceiver, so it receives and it communicates out back and forth. So it receives a signal and communicates. We have the 4-pin one, which one will actually we separated it. So one will actually be for sending out the signal, and the other one's for receiving the signal. So we put in the Arduino, we've set one to input and the other one to output.
Yeah.
So that's what we've done. So that's why there's 4 pins on there. Sometimes there's 3, but the 4-pin ones, heck, if they work.
Yeah, it's pretty neat that there's the option between the two, because I guess I've always seen ones like I'm looking right now online because I'm curious about these 3-pin ones, and I guess I've always seen ones that have like sort of the appearance of the ones that you guys sent, with like the 2 circles to it, and well, yeah, isn't that the way it goes? That there's always little things you got to know. The difference of how one works versus another. You got to program it differently. I made a Simon game using someone else's code, but I did my own circuit layout for it, and I used normally open switches when he used normally closed switches. So his code, coming through the code, trying to change it. I'm thinking to myself the whole time, this is exactly what it's like playing with electronics. Is that there's always one thing that's different.
Yes, absolutely.
You buy the wrong piece, and suddenly you got to redo your software. But
and that's another reason why you need kind of someone to help you along.
Yeah. But you know what? I always say that there's like a great experience of like that sort of tinkering moment. Calling up your friends who are into electronics and saying, hey, any ideas on how I can fix this? And it's, you just get everybody kind of just working on a solution. And but I mean, I think you got a really nice layout with these slides. Progressing through the code the way you did. I'm really looking forward to fiddling around with this a bit more, because as much as I am like fascinated by all of the Arduino related stuff out there, there's still a handful of sensors and things like that. I've never actually gotten to play with an ultrasonic sensor, so
yeah,
I'm actually really excited for this.
Oh, they're fun. Yeah. And please don't hesitate to let me know how to improve. So
yeah, after this Wednesday class, I'll shoot you an email with couple of things. Just do you have your PowerPoints up that I can go through them at all?
No, but I can share them with you.
Okay, yeah, you can send them straight to me with either my PA Cyber email or my personal email. Either one, I have a Google Docs account if you want to share them. I'd be glad to give some feedback and things like that as you guys keep going through your revisions.
Yeah, that'd be great.
Because if you're like me, your PowerPoints change a little every time,
Absolutely.
So yeah, just if you get a chance, if you send it my way too, I can also put them up for the students to be able to read through in case they missed class.
That's good. Yeah. And I forgot to mention, I'll send that list out tonight.
Okay.
About they need some tape, some pliers, some Allen keys is the most important one that they may not have. But they have a double-sided sticky tape, a 9-volt battery. I'll send you a list tonight. So
sure, yeah, I'll plug it up there. I'll email it to everybody, and just anything you think of. I have a parent email and a student email for everybody in this class.
Cool.
So it's pretty consistent that people are going to see the message same day, either the student or the parent will. So, yep.
Awesome. All right. Thanks, Joel. I appreciate it.
Have a good night. Talk to you later.